Morning or good afternoon or good evening, depending on where you are in the world. It's time for another Webinar Wednesday, and being the second Wednesday of the month, it is time for artificial intelligence. This month we are joined by Jeff Orkin. Jeff is a very well-known figure in the game AI community. His kind of seminal work was on the Goal-Oriented Action Planner, or GOAP, which he designed for Fear. And it paved the way for a range of kind of technical accomplishments and player experiences in games like Just Cause 2, Deus Ex, among many others. So having contributed to the state-of-the-art in the industry, Jeff's gone on, he's done a PhD at MIT's Media Lab. So his work there was on a thing called the restaurant game, and it kind of highlighted the way that NPC behavior could be synthesized from player telemetry. And that's work he continues today under his new startup, Giant Otter. So we are very delighted to have Jeff with us today talking about new gameplay, old AI. So as usual for a Webinar Wednesday, if you have questions, you can write them into the box on the right, and towards the end, Jeff will be able to get into them with you. So without further interruption, please, Jeff, tell us about new gameplay, old AI.
All right. Thanks a lot, Luke, and thanks, Tristan, for both of you for organizing this. Hello, internets. Let's see here. First slide is about me, but Luke just did a great job covering who I am. So I'm co-founder of Giant Otter, where we're building technologies very related to the things I'm going to be talking about in these slides. A lot of our work is based on research I did on the restaurant game project at the MIT Media Lab, and prior to that, I spent roughly a decade developing AI systems in the game industry. So new gameplay, old AI. I'm going to start out giving some motivation, explaining what I mean by new gameplay, where I see some opportunities to really move AI forward in games, and the ideas are drawing from some old ideas in AI from pioneers like Schank and Minsky, Kautz, Allen, Hammond. Some of these people are still active in the field because the field of AI itself is still relatively new. And then I'm also going to draw from people outside of what we usually think of AI, people working in philosophy and cognitive science, like Wittgenstein, Searle, and Bruner. And then hopefully there will be plenty of time for questions at the end. I have about 18 slides, and I think I can get through them in about half an hour, leaving plenty of time for discussion. So let's start with the motivation. So what do I mean by new gameplay? I'm referring to things like procedural content generation, interactive storytelling, open worlds, player stories, and lifelike intelligent companions. And you might note that all of these things already exist. We're kind of already living in the future. We're experiencing these new kinds of new takes on game design, really. And but I feel like while the designs have advanced, the AI hasn't quite kept pace, and we're still doing things in kind of more traditional ways with AI, yet these new designs open incredible opportunities to really push the envelope and see things we haven't seen before. And to kind of illustrate how far we've come just in recent years in really pushing design, I want to give one data point, talk about this project from the past called LMNO. That was the code name for a project that was later renamed the Escape Artist. So back around 2004, EA signed a deal with the director, Steven Spielberg. And one of the games in this deal was LMNO. It was a very ambitious project. Neil Young, an executive at EA, announced the project at GDC in 2004, and he said they were asking the question, can a computer game make you cry? You know, all of Spielberg's movies make you cry, but can you make a game that connects with you emotionally at that level? Unfortunately, this game maybe was too ambitious for the time, and it was canceled in 2008 and canceled again in 2010, ultimately permanently. So the game is a very Spielbergian story of an alien who comes to Earth, and the government agents are after her, and you're trying to help her escape. But what was very unique about it was the team was trying to break from the status quo of 12 to 20-hour linear storytelling and really take advantage of the medium of games and create something that was 1 to 2 hours, but highly replayable, leaving lots of opportunities for players to kind of forge their own paths through the game and encounter emergent behavior, and leading to player stories that that were memorable, that they'd want to tell other people about. The idea was that the game might have different scenes that could be played through in 3 to 5 minutes, but if a player wanted to, they could spend up to 45 minutes playing it and replaying it and exploring. I have a link. I think these slides will be shared. There's a link to a YouTube video of what the game looked like, and a very interesting expose about the behind-the-scenes story of what happened and the fate of this game that was on 1UP. 1UP doesn't exist anymore, but the Wayback Machine has a cached copy. So the point I want to make is that the ultimate cancellation of this game was less about the technical problems, although there were challenges there, but it was more of a business problem, a business and marketing problem. The industry at that time, 2004, 2008, 2010, the big studios, the AAA studios, only really knew how to sell these 12 to 20-hour linear experiences, and the marketing guys and the business guys didn't know how to sell a 1 to 2 hour highly replayable interactive story, and they doubted that the gaming public, the gamers, even wanted that, and so it was canceled. But fast forward to 2015 or even 2014, and times have definitely changed. We see Ken Levine, who founded and headed up Irrational Games and made this masterpiece of BioShock Infinite, kind of a masterpiece of the linear, more traditional linear storytelling, closing down Irrational in 2014 and saying that he started a new, smaller studio to make narrative-driven games for the core gamer that are highly replayable. And he gave a talk at GDC 2014 about what he calls narrative Legos, that you can kind of put these pieces together to create replayable stories. Another studio was just announced that it was formed, called Hangar 13, from some LucasArts vets and others, part of 2K, and they explained that they focus on player stories as much or more than those created by the developers. And then Shadow of Mordor came out recently and has been a major hit, and it has this novel kind of AI director system called the Nemesis system that creates unique enemies, and when you get killed by an orc, that orc becomes a named enemy that you want to get revenge against, and everyone is unique, has unique traits, unique name, unique appearance. And the question they were asking in developing this game is, how can we make narrative out of the gameplay? So the landscape has definitely changed. Probably, we can only speculate, but probably in response to what's happened in the mobile market, finding a much broader audience for games and getting people more used to the idea of short replayable games, and what's been going on in the indie scene with many more small games that can take risks in the way that AAA can't, but the ideas from them are kind of trickling up to the AAA studios now that they're seeing that gamers want these experiences. And the other thing we're seeing is a much greater interest in intelligent, lifelike companions in games. One of the most remarkable aspects of BioShock Infinite was Elizabeth, this character that accompanies you through most of the game and is extremely expressive emotionally and kind of helps subtly lead the player through the story. But BioShock was the more traditional kind of 12 to 20 hour linear narrative. And so it's one thing to make a companion that can play along when you know, under the covers the AI system knows the golden path that the player should be following, and the AI can take advantage of this to lead the player where the player needs to go. It's an entirely different problem to bring companions like this into procedurally generated worlds or open world games where the player may be pursuing any number of goals at any given time, and we want companions that can proactively be helpful and interesting to play with, and act kind of more as peers than kind of a scripted element. So if you look at a game like the Far Cry series, and other games have this too, they fill the world with wildlife to kind of bring the world to life and give the player something to do aside from the main missions. You can go hunting, and maybe you can kill animals to take advantage of a crafting system. But these animals are also threats. I find when I play the Far Cry games, I'm constantly being mauled by one animal or another. But I'll just use one of these animals, a tiger, to kind of illustrate the point of why it's so difficult to create an AI that can be helpful to the player in an open-ended gameplay situation. So imagine you're playing a game like Far Cry, and the player fires at a tiger. The AI system needs to ask, why did the player shoot the tiger? And there could be many different explanations. Maybe the player is acting in self-defense, doesn't want to get killed, his health is low. Maybe he's trying to take advantage of the crafting system, kill a tiger, get his pelt, and create a holster to hold another weapon. Maybe this game has a leveling up system, and the player's just killing things to gain experience points to unlock that next skill. Maybe there's an achievement system where you can earn an achievement for killing 3 tigers or something. Maybe the player doesn't want to kill the tiger. He wants to shoot it to make it angry so that it'll run off and attack anyone nearby, and maybe there's some enemy NPCs there. Or maybe he's trying to protect his companion, who he knows is running low on health and doesn't want the companion to get killed by the tiger. So knowing which of these goals the player is pursuing matters when we're trying to decide how the AI should respond. If the player is trying to protect the companion, we want the companion to be grateful and thank the player and allow the player to do this heroic thing for him. If the player is acting in self-defense, the player might be grateful if the AI stepped in and helped save him from dying at the mouth of a tiger. If the player is trying to earn experience points, we don't want the AI to step in because the player wants to get that kill. Or if the player is trying to create a distraction for the AI, we definitely don't want the companion to kill that tiger or even to make more activity that the NPCs might detect. And how the AI system is supposed to make sense of all this really relies on understanding the context in which the player shot at the tiger. Things like if the player's health is very low, then it might have been self-defense. If we know the context, we know that the player's been killing tigers lately, maybe he's trying to get that achievement or craft something. If there are enemy NPCs nearby and the player is using a silencer or a bow, maybe he's trying to be stealthy. So context matters. In the world of entertainment, there's this saying, content is king. Like, for example, people will pay to subscribe to HBO even though they have many free channel options because HBO has the best content. But the point I'm trying to make is to really move to the next step in AI for games. Context is king. We really need to think about ways to represent context and have the AI system understand the context in which behavior is taking place. So in the many years leading up to now, the focus on game AI has been on action selection, and we have a variety of solutions that have proven themselves to work well, behavior trees, planners, state machines, and we can still incrementally improve on these things, but for the most part I would say we've kind of solved the action selection problem for character behavior, and what we need to focus on now is instead of selecting the next action, we want to focus on behavior recognition, understanding the player, being able to infer the player's goals, and of course that will factor back into action selection. These are all factors that will help us choose the action that contributes to the goal that we infer the player is trying to achieve. In this presentation, I'm also going to talk about language because, like that tiger example, there are many situations where, based on what we can observe, the goal the player is pursuing might be ambiguous, and language is a very helpful tool for disambiguating behavior. If we have characters that can ask clarifying questions when they're not sure how they can help the player, you know, your companion might ask you, do you want help with that? Should I hold back? Or perhaps the player will even have ways to say simple things to the companion, or perhaps when the companion starts to do something that the player doesn't want him to do, the player will have some means to use language to say, stop, don't do that. And in general, language is a way of the AI characters expressing their intentions. So at a minimum, the player can be aware of what the companions are trying to do. So let's talk about old AI and how this contributes to this idea of giving AI more context for behavior. So we'll start with Roger Schank, who in 1977 published this book about his research, Scripts, Plans, Goals, and Understanding. So Schank was interested in the problem of story understanding. He was asking, how can we get computers to understand stories the way humans do? Humans have this incredible ability to fill in gaps and understand things that weren't explicitly said in the story. And Schank focused initially on stories that happen in restaurants because that's something that most people can relate to. So imagine there's a story like John went to McDonald's. He left, he got in his car. When he got home, he opened the bag, and he was really angry. We can ask questions that a human can easily answer, like why was he angry? probably because what was in his bag wasn't what he ordered. What was in the bag, we know it was food. Did he spend money at the restaurant at McDonald's? Most people would say yes, he did. But a computer doesn't know these things because they're not stated in the story itself. They rely on background knowledge, kind of common sense that we all have. And that's a form of context. So Schank proposed this idea of scripts. Scripts have kind of a negative connotation in game AI, but Schank was referring to something different, not a linear hard-coded script like something we'd write out in a scripting language, but a script is more of a representation of context, a representation of everything that could happen in a restaurant that we can draw from to fill in gaps and understand things that weren't explicitly stated, things that we didn't observe directly in the story. So a script to Schank is something that has different roles. Like in a restaurant, there's a customer, a waitress, a chef, a maitre d'. There are goals that different characters are pursuing, either individually or jointly. There are different plans that can be used to satisfy those goals and different actions that can be sequenced into plans. And there can be many, many different plans to satisfy each goal, and the goals can be organized in many different arrangements. I'll point out some pieces of related work. Around the same time period, Marvin Minsky published an AI memo titled A Framework for Representing Knowledge that proposed something called frames that were very similar to Schank's scripts. And my PhD research, I worked on a project called The Restaurant Game that was very much inspired by Schank's work. Back in 1977, the way they created scripts was they got grad students to hand author all of the different ways things might play out in a restaurant. What I did with The Restaurant Game is tried to crowdsource the creation of those different scripts, different plans that could play out in the restaurant. We got 16,000 different people to play as customers and waitresses anonymously paired online, and generated a very complex model of language and behavior that you might observe in a restaurant. Relating this back to that question of why did the player shoot the tiger, imagine if we had something like the Far Cry script or the hunting script, or a script for some stage of the Far Cry game. We could use information in that script to infer the player's goals and figure out what different roles could contribute to satisfying those goals, what role the companion could play that would actually be helpful and rather than disruptive. Schank and Minsky in the 70s were kind of the first ones to be thinking about this problem of how to represent background knowledge, how to represent context. And if you actually read this book, it's full of very interesting ideas, but the specific implementation is full of very unfamiliar terminology and ideas that aren't so straightforward to implement. But in the years following this work, others kind of picked up where they left off and came up with more formalized ways to represent context and recognize behavior. One approach is called plan recognition. This is a paper from 1986 published by Kautz and Allen. What it describes is a hierarchical model of behavior. And this representation is something that's probably much more familiar to game developers. It kind of looks like a behavior tree or an HTN plan, but rather than using it for action selection, we're using it kind of in reverse to recognize behavior. Ideally, you could use the same representation for both recognition and action selection. As a side note, you'll see that this is a representation of preparing a meal, and for some reason, a lot of this early work in AI focused on restaurants and food, and I can only imagine these researchers were very hungry. Okay, so if we look at this diagram, what you see is hierarchical structure where there are these thick arrows that indicate specializations of different actions, and then thin arrows that indicate actions that you take to contribute to a higher level action. And this forms what they called an action hierarchy. So make pasta dish is an action contributing to preparing a meal, and making spaghetti carbonara, fettuccine alfredo, or fettuccine marinara are specializations of make pasta dish. And you can see this particular diagram encapsulates making a chicken dish or a pasta dish. And the way one could use this is, imagine if you were making like a kitchen helper robot. And the robot observes that the human just made some marinara sauce. It can infer from that that the human's preparing a meal, but there's some ambiguity about whether they're making a chicken dish or a pasta dish, because there's chicken marinara and fettuccine marinara. But if the robot has also observed the player boiling water, then it has more information, and it can infer that the human is indeed making a pasta dish, and the robot could be proactively helpful by making noodles or opening a package of noodles. So this is a representation that could be very directly applied to games, where perhaps we could represent ways to accomplish achievements or craft things or goals for self-preservation. So these actions that break down into sub-actions at some point could be considered goals. And as this field progressed, Schank kept thinking about these problems of how to actually leverage representations like this in practice, and realized that one of the big challenges was plan retrieval. So if you have this representation, like maybe an action hierarchy or a different representation, how do you retrieve relevant plans that exist in memory when you need them? And what do you do if there isn't an exact plan existing for the problem you're facing? So he wrote a book about this theory of dynamic memory, kind of a way to index many related examples so that you can find them when you need them, and ways to adapt them if they don't quite match what you need, and then you can cache the adapted versions. And some of Schank's grad students took these ideas and formalized them into what became kind of a major field of AI. These ideas led to his student Janet Kolodner pioneering case-based reasoning, and around the same time a student named Christian Hammond introduced a similar idea called case-based planning, which is like case-based reasoning, but focused on planning to solve goals, to solve problems. So Hammond introduced these ideas in a paper called Chef about about a system that can help figure out how to prepare meals. And he explains that case-based planning is based on the idea that a machine planner should make use of its own past experience in developing new plans, relying on its memories instead of a base of rules. Memories of past successes are accessed and modified to create new plans. Memories of past failures are used to warn the planner of impending problems, and memories of past repairs are called upon to tell the planner how to deal with them. So I'll show you one example from his paper. So overall, case-based planning, what case-based planning is using previous examples to solve new problems, and it's composed of two steps. There's the plan retrieval, where you find similar examples to solve problems similar to the problem you're solving now, and adaptation where necessary, where you can adapt a cached plan to fit your current needs, and if it's changed, you can cache the new version. So Hammond gives this example of someone who wants to make a chicken and broccoli dish, but in the planner's memory, there's only a beef and broccoli example. So you can modify beef with broccoli to turn it into chicken and broccoli. So it's modifying the plan by substituting chicken for beef. This person wants chicken and snow peas, so it recognizes that snow peas can be substituted for broccoli. And then it has kind of this post-processing critique step where there's a critic that recognizes that you need to chop the chicken and debone it, which is different than what you would need to do with a side of beef. I'd also like to point out some more recent work on case-based planning that's more directly applied to games that's definitely worth checking out, from Santiago Ontanon and Ashwin Ram. They wrote quite a few papers looking at applying case-based planning to a real-time strategy game called Wargus, which is an open source version of Warcraft 3. Definitely worth checking out. So now let's talk about language in games. Language in games and dialogue in games has not really changed in many, many years. We still have systems that are very reminiscent of what we were doing in adventure games in the 80s, where we have multiple choice dialogue trees that are largely predefined. The dialogue is divorced from the rest of the gameplay. You go into kind of a dialogue mode where you choose dialogue options, or where language is used in the more action-oriented gameplay. It's really used for effect. It's layered on just to kind of add texture to the world by having characters say sensible things while they're interacting. But it's not integrated with the action in the way that it would really need to be for more open world games with companions who are proactively trying to help the player. Language is really a tool they could leverage when they're interacting with the player. We want them to be able to dynamically talk about what they're intending to do, perhaps ask the player clarifying questions when there's ambiguity, perhaps give the player a way to dynamically strike up a conversation with the companion. Imagine games where the right trigger lets you fire a weapon and the left trigger lets you fire your mouth, so to speak, and at any time you could dynamically generate some choices of things you might want to say or ask of the companion. This becomes an intractable problem to author all of the content in a game that's sufficiently open-ended. And there are ideas from decades ago from cognitive science and philosophy that hint at the directions we might want to go to support such language interaction in games. So the first one I'll point out is philosopher John Searle's theory of speech acts, which is actually based on some earlier philosophy work by Austin. The idea behind speech acts is that language is a form of action, just like physical action. We can use language to take actions in the world that affect the state of things in the world, just like physical actions do. And if that's the case, that language is an action that we can treat uniformly with physical action, then we can fluidly intermix language and action. Imagine having a behavior tree or a planner where every primitive could be something you do physically with an animation of your body or linguistically by saying something in the world. But there's this problem of language is almost infinitely varied. So what does it mean to say many different things in the course of behavior? And the answer to that, again, comes back to context. We can use context to understand the meaning of what characters are saying. So these two other works present very similar ideas. Jerome Bruner was trying to understand or propose theories about how children learn language, and he has a theory about activity contexts, that language is given meaning by the activity in which it's used and the point in that activity in which it's used. And he uses the example of one of the earliest bits of language that children learn is through the game peekaboo, where a parent looks at the child, covers their eyes, says peekaboo, and then uncovers their eyes. And over time, through repeated exposure to this, children learn that there's this sequence and learn that the word or the phrase peekaboo sets up an expectation about what's going to happen next, that the parent's going to uncover their eyes, and the character recognizes that this is kind of a little script where there are different roles that the parent and the child are playing, and over time the child can learn to reverse the roles, and the child can be the one to say peekaboo. And Wittgenstein proposed this idea of language games, where peekaboo is kind of one of these language games. But he goes beyond child language and theorizes that language in general is made up of many of these games that allow us to make sense of language in particular contexts. So the points I'm making here are that language is a form of action, and we want to be able to treat language as a common currency with action, meaning in our behavior trees or planners, each primitive can be either an utterance or a physical action. And what the utterance means is defined by the context in which it's used. So we kind of have this feedback loop where we can use language to disambiguate the behavior that we're recognizing with context, but at the same time the context itself gives meaning to the language. A couple points of related work to look at for kind of more technical actual implementations of similar ideas to this. Chuck Rich and Hansen published a paper at AID where they used plan recognition based on an HTN planner to understand and generate unique utterances in a miniature game. In their paper, A Non-Modal Approach to Integrating Dialogue and Action. And that work is actually an extension of Chuck Rich's earlier work on a system called Collagen that uses language to create a collaborative user interface that can work together with a human to accomplish a task. I think they looked at tasks like travel planning, where it could use language to as a form of action to connect with a human user to accomplish a goal. So finally, my last point is about emotions. How do we make characters that express emotion? And it's based on ideas from Marvin Minsky. Minsky published 2 books many years apart, The Society of Mind and The Emotion Machine. Both of these books present very similar ideas, but described in different ways. The Society of Mind is made up of 1-page essays and that are all somewhat related to each other, and the Emotion Machine brings them together into a more coherent theory. But they cover kind of the same material, and they're both very worthwhile to read. And the Emotion Machine it presents this theory of how human cognition works, where emotion is central to our reasoning process. So if we think about how emotion is typically implemented in games, if it's not entirely scripted, the way it's often implemented is by putting behaviors into buckets. Like imagine a behavior tree where the top level node splits the tree into different behaviors for relaxed, suspicious, and alert NPCs. This is a practical approach, and it does work, but it's very heavy-handed and kind of makes a black and white distinction between different emotions, when the reality is that there's much more of a gray area. Emotions are more fuzzy, and you're often not 100% expressing one emotion or another, but your behavior is subtly influenced by a variety of emotions at once. And if we could create characters, companions in games that had a more nuanced representation of emotion, this could lead to more emergent behavior and characters that behaved in more varied ways that hopefully could lead to much more interesting player stories about the way their actions affected those around them and led to different outcomes in the game. So let's look at how Minsky talks about representing emotion, and it's very different than this idea of putting behaviors into buckets. Instead, he imagines that the mind is made up of agents. In Society of Mind, he called them agents, and later in the Emotion Machine, he refers to them as resources. But the idea is that there are many different small programs running in the brain, and what emotions do is they turn on and off different agents, and your emotions are kind of the composite of all of the agents that are currently on or off at a given time. And so an emotion like anger might suppress certain agents that would normally encourage you to execute more rational behavior, because you're going out of control with rage, where fear might turn on certain agents that make you act more conservatively because you're more worried than usual about things. And Minsky gives this example that I thought was very poignant about the emotion of love. And he has this quote where somebody is describing their feeling of being in love, where they say, "I've fallen in love with a wonderful person. I scarcely can think about anything else. My sweetheart is unbelievably perfect, of indescribable beauty, flawless character, and incredible intelligence. There's nothing I would not do for her." And that seems very positive. This person is infatuated. But then Minsky breaks that down, kind of dissects it, and what you see is someone who says, this person I'm in love with is wonderful, indescribable. I can't figure out what attracts me to her. Part of my brain's not working. I scarcely can think of anything else. Most of my mind has stopped working. unbelievably perfect, incredible. No sensible person believes such things. She is a flawless character. I've abandoned my critical faculties. There's nothing I would not do for her. I've forsaken most of my usual goals. So I think it's very interesting to think about how you could apply this to games and on a either more individual level of different goals and actions, or the sensory systems that contribute to those goals and actions, turning them on and off based on different emotions. So my last slide, I've got some shameless plugs of other things you might want to look into. There's a link to my PhD thesis describing my work with the restaurant game. It's titled Collective Artificial Intelligence Simulated Role-Playing from Crowdsourced Data. If you'd like a more condensed version of that, in the GDC Vault from 2013, there's a video where I gave about a half-an-hour talk. I'm in the second half of the video of the AI Summit talk for Off the Beaten Path, Non-Traditional Uses of AI, and it's a summarized version of my PhD work. Giant Otter is where we're pursuing actually building out commercial versions of a lot of these ideas. My personal website and Twitter account are listed there. I moderate the Game AI group on Facebook. If you want to join the discussions about AI and find out about various upcoming events and papers and whatnot. And finally, I have a list of useful books, books that I've found useful for game AI. I haven't updated it in quite a while, but I think a lot of the books there are still quite relevant. So I think we have about 15 minutes for questions. I think Tristan can moderate the questions, and I'm happy to answer.
Thanks so much, Jeff. Let's give it a couple of minutes or seconds to allow people to type if they have any questions.
Sure.
And if not, then you've articulated everything wonderfully. All right, we have one from Ted. Ted asks, have you looked at semantic web techniques such as triples in use for knowledge dialogue, and what do you think about that?
I haven't, I'm not familiar specifically with triples, but there's definitely opportunities to leverage kind of third-party external sources of knowledge and bring them into games. I've played around a little bit with things like Wordnet for trying to understand the meaning of words, and ConceptNet is something that came out of the MIT Media Lab based on the Open Mind Common Sense data. I think that's kind of a ripe area for exploration. I think one of the challenges we have in games is that you need directable, controllable, reproducible behavior, and sometimes when you draw on these external knowledge bases, the results you get aren't correct all the time, aren't what the game designer wants to happen. So I think you have to look at these as tools that can be useful, but you still want a human in the loop to vet what actually goes into the final model that characters are drawing from.
Okay, great. Alex asks what looks somewhat cheekily, because there's a smiley face, what kind of secret technology are you working on now based on all of these ideas?
It's not secret at all. We just, you know, development is never as fast as you'd like it to be. At Giant Otter, we have 2.5 engineers. Graham Pentheny is sitting next to me coding away as I speak. And what we've been working on is taking very directly the ideas from my PhD thesis and making them scalable, running on the cloud. They're running on Amazon Web Services. And we're creating a platform where we can record data and structure it in an indexable database and use that to power characters in games. And to be honest, we're still trying to figure out exactly whether we're trying to make something for game developers to use or whether we're trying to make novel games ourselves. We're doing a little bit of each right now, and hope that we have things to show in the coming year.
Okay, Chris says, great talk. He's curious, what are your thoughts about the smart object approach used by The Sims?
That's a great question. When I was in industry, I used smart objects pretty heavily, very inspired by The Sims. On No One Lives Forever 2, especially, we wanted characters that really seemed to live in the world because you were a spy and you were sneaking around and we wanted them to do interesting things. So we put all kinds of smart objects in for these guys in these enemy kind of World War II era military camps to be wandering around, taking smoking breaks, going to the bathroom, working in offices, rifling through file cabinets. And I had an article that you can look up in, I think it was in AI Game Programming Wisdom 2 about kind of lessons learned implementing a system like that. But when I went to work on this restaurant game project, which is, the restaurant game itself is a very open-ended kind of sandbox environment where people can do kind of regular restaurant things like sitting down and ordering a meal and eating a meal, but they can also do crazy things like stacking pies and climbing onto the roof of the restaurant. And what I found was that smart objects, I feel like, are sort of not powerful enough if you want a very open-ended environment where there are many different objects that can each be used in multiple different ways. And if you want objects that can be used in multiple behaviors over time, where like one character gives the object to someone else who uses it in a different way, it gets very complicated to try to code up a smart object to handle those things, because smart objects by their design are very modular and object-oriented. So it's kind of in more recent years I've started to feel that a different, more case-based approach is better, where the objects themselves don't really have meaning. They're given meaning by the examples or narratives or plans, whatever you refer to them, in which they're used. So the meaning of food is given by the way characters interact with food objects in the restaurant. And I should mention, kind of related to Alex's question, we are working on relaunching the restaurant game from Giant Otter, the restaurant game HD. The original restaurant game was created with art assets kind of borrowed, in quotes, from The Sims 2, but we've created a new restaurant in Unity with original artwork. So we hope that people can once again enjoy that sandbox experience soon, but we don't have it up online quite yet.
Chris says, thanks, that was a great answer. There are no other questions, but we will give it a minute. Chris, do you want me to unmute you so you could plug your next week's session? Chris?
Well, yeah.
Hi.
Hi. Hi there. So I'm unmuted?
I'm unmuted.
Okay, great. Hello, everyone. So, hi, I'm Chris Wambach-Kroll. I'm curious. I love lurking on the AI stuff because I worked on The Sims and some other AI-driven games, and it continues to fascinate me. Next week at this time, we have a session by Ethan Levy about planning for monetizing in games from day one, and this is in the game design thread. So if you're interested in that, which a lot of people are, then spread the word and register and show up for that. I had another follow-up kind of a thing here on the AI because I'm really fascinated by the subject. Have you ever considered a scenario, this just kind of just popped into my head, a scenario where the AI is using environmental objects to create games for themselves, right? Because I was thinking in your restaurant scenario, all these objects are used around this, eating food paradigm, and which is preparing the food and eating the food and all that. Whereas, as human beings, we certainly would love to see the AI pick up the food and start to throw it, and start a food fight. Which led me to think, wow, what if you actually just had a game world where you have these objects and the AI just is like real people running around finding ways to create emergent gameplay from the things that are in their environment.
I love that idea. Yeah, I mean, I think that's a direction we're sort of trying to go. Like, our process isn't, it's not an online learning process where, like, as soon as players start creating and interacting with objects, the AI can instantly join in, but we have more of an offline iterative process where we take a bunch of data and see how were the players interacting with the objects in the world, and what behaviors do we want to feed back into the game. So there's kind of a human in the loop that there's more explanation in some of the links that I pointed to on that last slide, but we have a process where humans tag the data and explain what events are occurring. So I can certainly imagine applying that to procedurally or a user-generated world where there's a widget that previously had no meaning, but by seeing the way the players interact with it, humans can later go in and tag that as the fact that they're using it as a weapon or a musical instrument or whatever the case may be, and that could then feed back into the game, and AI characters could then do the same. I think there are open questions about how you do that efficiently so that you can minimize the lag in players creating behaviors and seeing those behaviors feed back into the AI.
Sorry,
is anyone still there?
I muted myself and was talking.
Okay.
I didn't realize. So that's great, and that puts us right at the top of the hour. Thank you so much for the talk, Jeff.
All right. Thank you all for attending.
And we will see everybody next week. Thanks, everybody.
Okay. Bye.